Today we're going to look at how to find the equivalent resistance of resistors that are wired in combination. That means that some of them are wired in parallel and some of them are in series. This is a pretty complicated problem, but I thought it would help illustrate the ideas behind it and hopefully make it easier for you to solve some of the simpler problems that you're going to be looking at. So with this, what I really kind of need to do is put them together piece by piece. So looking here, the first thing I want to look at is what's going on right here in the bottom, right here, 4 and 5. That's the first thing I want to do. I want to find out what resistor I could replace those two resistors with and not change the overall resistance of the circuit. So I'm going to look at just that by itself, and they're wired in parallel. So I know that the total resistance of R4 and 5 together is going to be equal to 1 over R4 plus 1 over R5, and then take the inverse of that. I'm going to put some numbers here to make this a little bit more concrete. So let's say that R1 here, we're going to say that's 15 ohms. Let's make R2 54 ohms, R3 48 ohms. R4 is going to be 50 ohms. R6, or I'm sorry, R5 is going to be 60 ohms. And then R6 will be 36 ohms. So to find the equivalent resistance for those two resistors, we're going to do 1 over 50 plus 1 over 60, take the inverse of that, and we're going to come up with a number which is 27.3. I calculated this earlier, cheating a little bit there. So what we can do is we could take these two resistors and take them out and replace them with one resistor that has an equivalent resistor or has a resistance of 27.3 ohms. So what I'm going to do is redraw the whole circuit, but instead of the 50 and 60, I'm going to replace it with the 27.3. So we start here at point A. We have our 15 ohm resistor here. These are unchanged. The 54 up here, 48. But down here, instead of those two in parallel, I'm going to put a 27.3, which is what we calculated. And then this is 36 ohms. Then we come over to point B. All right, the next step is going to be that we want to take and find the equivalent resistance of resistors 2 and 3, I guess, the 54 and the 48. Those are wired in series, so they're pretty simple. You're just going to add them together. So we'd say 54 plus 48, and that comes out to be 102. So we could replace those resistors with one resistor that has 102 ohms value. And then we can do the same thing down here. So this right here would be 27.3 plus 36, and that's going to come out to be 63.3 ohms. And I could redraw this again with replacing those with the values we just calculated. So we still have our 15 ohms here, but on the top here we're going to put one resistor of 102 ohms that replaces the 54 and the 48, and then on the bottom here we'll put one resistor at 63.3 ohms that replaces the 27.3 and the 36, and then we come here. So we're getting simpler and simpler. All right, so then the next step is going to be to go and figure out what these resistors are in parallel. So that's going to be that we're going to take 1 over 102 plus 1 over 63.3, take the inverse of that, and that comes out to be 39.1 ohms. So then we can go again and replace that with the value we just calculated. So we have 15 ohms here, and then that whole thing gets replaced with 39.1 ohms here to get to point B. And so what that means, that 39.1 ohms, if we go back up to the top, this whole portion here actually has a resistance of 39.1 ohms. We just simplified it bit by bit by bit. And here, these are wired in series, so we just add them together. 15 plus 39.1. My writing is all over the place. I'm a little sloppy today. We get 54.1 ohms. So the whole resistance from A to B is actually equal to 54.1 ohms. Okay, I hope that made sense and you were able to follow along. Let us know if you have any problems.